Hi everyone, in this video we'll be doing the chapter number 25 of CMT level 1 and it's called Inferential Statistics. In further videos I'll try to also cover the entire thing which is given in the textbook as it is, but for now we'll be doing from this notes, and these notes are prepared exactly from the textbook, so it's not like you're missing out on anything. So now we are beginning with statistics, the entire section of statistics in CMT level 2. The first thing we need to understand is what is data and what are numbers, right? So in trading or in statistics in general, we have a lot of data and we have a lot of numbers which is present in front of us. So when we have like a lot of data and we have like a lot of numbers, it is very difficult to comprehend the data, and it is very difficult to organize the data and make meaning and make sense out of it. So for that purpose, statistics has come into existence, and we have two types of statistics. The first one is descriptive statistics, and the second one is inferential statistics. When we talk about descriptive statistics, we can identify and we can know the meaning of descriptive statistics by just reading the name descriptive. So, something which is very elaborate in nature, which is very descriptive in nature, is known as descriptive statistics. So, to describe or to summarize data using various types of quantitative tools. Now, that is what is known as descriptive data. Descriptive statistics is also known as summary statistics, so keep that in mind. Moving on, we have what is inferential statistics. Now, inferential statistics is when you basically create inferences or you draw conclusions and you draw inferences based on the descriptive statistics. So there are no guarantees or certainties in real world situations. Nothing can be sure, everything is just an assumption. So we can only predict something with only certain confidence because of randomness. Everything is very random in this world and random things can occur, due to which we need to keep in our minds that there is an element of randomness which exists. For example, let's say flipping a coin. If you flip a coin 5 times, what is the possibility of getting H or head in the third time? All the 5 times or never. So, now this is what is known as the concept of statistical inference. It is all about accounting for the randomness so that we can infer the properties of population based on sample and make propositions about scenarios we are getting to encounter. So this is how a statistical inference looks like. First, we have a sample data or we have the estimate. By seeing the estimate, we can make the population properties. We can write down and we can identify the population properties, and then we can understand its nature. After we understand its nature, we can see the randomness and we can see that how it's going to basically affect the future scenario. Moving on to what is hypothesis testing. So, hypothesis testing is basically a way of making decisions using the statistical inference. Okay. So, when we talk about hypothesis, you need to keep two things in mind. We have an H0 and an HA. So, H0 is null hypothesis. When you talk about null hypothesis, it means you just need to keep in mind that it's talking about the status quo or the starting point. Whatever your starting point is, that is your null hypothesis or your H0. An alternate hypothesis is something which you want to prove. So this is what you actually want to prove, that it is right. So when there's no change and when there is status quo, then that is what comes under null hypothesis, and situation will change, or this is what you want to prove, that is the alternate hypothesis. In order to prove that the alternate hypothesis is true, you have to be able to reject the null hypothesis. Very basic. In case you fail to reject the null hypothesis, that means that the data is not significant to prove that the alternative hypothesis is true. In hypothesis testing, to reject null hypothesis, we set a confidence interval that will be used to judge if there is sufficient statistical significance or not. Confidence interval and statistical significance. So that is the level which shows us whether the data is enough and whether the data is sufficient enough to conclude it, to reject the null hypothesis or not. Let's take an example of we want to invest 1 lakh rupees to get a return of 15% for 1 year. Then, in this particular situation, what are we going to do? So, we have ROI, the rate of return on investment on the y axis, and we have high risk on the left axis. So, let's say we took a confidence interval, and then let's see the example. To judge the above scenario, you need two statistical parameters. The first thing is you need a confidence level and you need a confidence interval. And if the confidence level is 95%, then the significant level is 0.05%, 0.05. So one thing you need to keep in mind is the significance level is also known as the p value. So if the question gives you significance level and asks you to find out the p value, you know that the significance level is the p value. So there are various ways for hypothesis testing, right? There are two types of tests which we can talk about. The first one is the t-test and the second one is the chi-square test. The t-test is basically used to compare two means, whereas the chi-square test is used to determine the relationship between two categorical variables. So whenever you're talking about categorical variables, you need to know that you need to use chi-square test to find it. But whenever you are have to compare two means, you can use the t-test. So this is a normal distribution which is given, okay? And you can see that this area is 95%, which is the confidence level. And the shaded region is the HO, right? Which is basically the 5%, the rest 5%, which is not in the confidence level. And P is 0.05. Now, why am I saying 0.05? Because that is the statistical significance. So, if your value falls in the shaded region, one sec. Yeah, if the value falls in the shaded region, then you have to reject it. You have to reject the null hypothesis. If it falls on this particular area, then you can comfortably reject it. Sorry, then you can fail to reject. Again, I think I just said opposite by mistake. If the value falls in this particular area except for the shaded area, then you can basically say that you fail to reject. But if the answer falls in this shaded area, then you can comfortably reject the null hypothesis. Now let's talk about the base rate fallacy. What is base rate fallacy? Suppose there are 1000 investment strategies. Say you are able to always construct a statistical hypothesis test that gives you 95%. Due to this is conference level, don't get confused. Due to market randomness, 5% of non-valid strategies show positive results. Let 1 in 1000 actually generate the return on investment, and what is the probability that the selected strategy is valid? So only one is valid. You need to keep that in mind. And about the rest 999, you need to also see that you have 5% of non-valid strategy. So 5% non-valid strategy is 49.95. So what is the total that you have? You have for 49.95 plus 1, right? Which is going to give you the ROI. But this 49.95 is basically the false positive ones, right? What is the probability? Probability is 1 upon that number, which will give you around 2%. So this situation can be improved by increasing the confidence interval by, let's say, 99.99, and then you can see how the probability also improved. Then we come to the very important concept, and that is correlation. Correlation is basically the association between two variables. In this case, we can see the correlation between two stocks, or we can see the correlation between two commodities, or any two instruments, or let's say we can see the correlation between, let's say, Tesla and the S&P 500. So correlation is basically the association between two variables, and it is measured on the scale of -1 to 1. When we have a plus 1, that means that there is a strong positive correlation, and when there is minus 1, there is a strong negative correlation. And if there is 0, then if the value of correlation is 0, that means that there is no correlation at all. The formula that is used for calculating correlation coefficient is given by Pearson correlation, and the formula of Pearson correlation is written as R. R is basically the Pearson correlation coefficient. And the formula of it is basically, let's say there are two variables, x and y, whatever two we want to find the correlation between. So the correlation R of xy is basically the covariance xy divided by the standard deviation of x and the standard deviation of y. How do you find the covariance of x and y? The formula of covariance of two variables x and y is basically the summation of x minus the mean of x multiplied by the y minus the mean y divided by n, which is the number of observations, which is basically the periods which we are using, n minus 1. So again, the formula of correlation coefficient R of xy is covariance of xy divided by the standard deviation of x and standard deviation of y. And the formula of covariance of xy is basically x minus mean and y minus mean multiplied divided by n minus 1. So this formula is important since it can be tested in the question. You can pause this and you can just look at how to calculate the same. Moving on to the variable independence, or the R squared. Now, R squared is basically known as the coefficient of determination. It is also known as R squared, and it is signified with the symbol of R square, or R to the power 2. So one thing you need to keep in mind is that Pearson correlation can capture only linear relationship, right? So only if there is a linear relationship you can identify it using the Pearson's correlation R. But if you don't have the if you don't want to find the linear relationship, for that purpose another statistical parameter is used, and that is known as the coefficient of determination, or R square. Now R square basically measures the proportion of variance explained in one variable by the other variable. So it is basically the square of the correlation coefficient. So once you find R, if you square the value of R, or if you square the value of the Pearson's correlation, then you get the coefficient of determination, which is R square. Now let's talk about what is correlation versus the causation. Causation is basically the cause and effect relationship, right? So you need to keep in mind that correlation in itself is not useful to predict the causation part of relationship. Okay, so you don't know why a particular thing is caused by just looking at the correlation. What is autocorrelation? Autocorrelation is also known as serial correlation, and it describes how a variable correlates with itself over time. So serial correlation or autocorrelation is the relationship between the same variable with itself over the time. Correlation basically talks about the relative strength, whereas the autocorrelation talks about the momentum. Now let's talk about regression analysis. Now even analysis is a very important concept when it comes to statistics. So to quantify the association between two variables, we use regression analysis. Using this regression model, we can see unseen data, and so we can basically predict. So until now, when we were talking about correlation or causation, we can just talk about the data which is historical in nature. Now, how do I find out the data of something which hasn't happened yet? How do you predict the future outcomes? For that purpose, we have regression analysis. Now, general form is equal to y is equal to the fx plus e. E is basically epsilon, or it is basically error, or which is a very, very small number. So y is our prediction, and fx is some function, and e is error. And why are we adding the error function? Because of the concept of randomness. Talking about the linear regression model, it is the formula of a line itself. So y is equal to bx plus a, where y is the dependent variable, right? And b is the independent variable. A is the intercept on the y axis. Okay. So B is again also the regression coefficient. You need to keep that in mind. B is the regression coefficient and B is the slope of the line, whereas A is the y intercept and it is the value of the y when x is 0. Simple stuff. You know what is dependent and what is independent. Y is dependent variable here. B is the slope of the line and it is also the regression coefficient. And A is basically the y intercept. Linear regression model is often fitted using the least squares model or the least squares method. By least square method, I am talking about finding a best fitted line or finding a line that basically minimizes the squared sum of differences between the estimated values and the actual values. So the difference between the estimated values as well as the actual values. So the formula which we saw, y is equal to bx plus a. Now let's talk about it in detail and let's talk about how to calculate the formulas. So when we talk about b, which is the slope of the line or the regression coefficient, we get x minus mean multiplied by y minus mean divided by x minus mean square. And what is a? A is basically y mean, mean of y minus b multiplied by x mean. Now this can be a little bit confusing, but if you write the formulas once or twice, you'll be able to understand them better. So I hope it's clear with you. The value of b is basically x minus mean multiplied by y minus mean and summation, because we are taking the values of all possible outcomes, divided by the summation of x minus mean again. So easy way to remember this is basically x minus x in the numerator and x minus x in the denominator. The only difference is that there is a square in the denominator. And the value of a is basically y mean minus b of x mean. So that's it for chapter number 25. Let's quickly again revise the formulas of the same. So the Pearson's correlation or R is basically R is equal to covariation of xy divided by standard deviation of x and standard deviation of y. Now, how to find covariance of xy? We have x minus mean, y minus mean divided by n minus 1. That is the covariance. Then to find r square, you are just again squaring the value of the Pearson's correlation coefficient, which we know how to find out. And then when we talk about regression, you know that the formula is fx plus e. So y is equal to bx plus a, where a is the y-intercept and b is the slope. So b is basically x minus mean, my y minus mean divided by x minus mean whole square, and a is basically mean of y minus b x mean.